Okay, so I'm still working on my sound, trying to improve that, doing the best I can with the primitive equipment I have. So I've titled this "What is Polar Shift?" because this is a rather complicated science topic, and many people have difficulty, don't remember their science very well from school. And it's really important that you learn science. If I get enough support, I'll do more videos and teach people more about the scientific things. But today we're going to talk about a polar shift, which is not a common topic of science. First of all, I want to explain some things about our planet. Our planet is spinning, and the science behind it. This fellow here has a golf ball, and he's just elevated the golf ball with compressed air, and that golf ball is spinning. And the reason it's spinning is because the compressed air is pushing the golf ball up into the air, and the gravity is pulling the golf ball down, and the two opposing forces cause it to spin. And that's exactly what's happening with our planet. We have gravity pulling us in towards the sun, and we have the solar wind pushing us away, and that's why we spin. Okay? This is a artist's conception, shows you the solar wind from the sun. It's a strong force that's pushing out, and it goes around our planet. There is a protective barrier to protect us from the solar wind, and the Earth is made of nickel and iron, like a big transformer. And so as the electrical properties of the solar wind come across here, they create like an electromagnet with our planet. So it's the atmosphere and the space is a highly electrical place, and so this is a strong force that comes across our planet, and it's not a perfect sphere because it's coming pretty strong and it pulls out to the side. And there's some instruments, also scientific instruments, that measure this, but we're not going to get into that today. Our planet is rotating. Everybody knows that. It rotates one revolution in every 24 hours. And typically when we think about the rotation, this is the way we think. The North Pole is at the top, the South Pole is at the bottom, and we're going around in circles all the time. This is the way it's portrayed in many videos and movies and things, but that's not the way it works, okay? The Earth has a tilt. If you draw a line through the center, from the North Pole to the South Pole, there is what we call an axis. That's an invisible line of the planet. It's just like there was a great big pole or pipe that was between our planet and went down the center, and so we rotate on that. But it's invisible, okay? There's no actual physical object that it rotates on, like a top or a globe. It's all invisible. All right. So it spins on this axis, but the Earth is tilted, and we talked about this in one of my earlier presentations. We called this Earth's axis is being tilted, and typically it's represented at 23.5 degrees. Oh, I put my PayPal information in case the videos are downloaded, and someone, if they want to support, these videos take a long time. That's fine. I won't object. All right. Now, there are actually 4 poles. There is the North Pole, the physical North Pole, the magnetic North Pole, the physical South Pole, and the magnetic South Pole. And they're not the same. The magnetic North Pole has been moving for quite some time, and they've been measuring it for a long time, and this information is from NASA, and these measurements in here are where it's been moving, and from 2001 out are estimates, because the fellow who was doing this, his airplane would not go any further than this area here, so they stopped getting actual. And of course, this is barren country up here. They stopped getting actual measurements, but there are some people who have actually picked up this chart and updated it, and they're using ships' coordinates. Ships out here. There's a tourist ship from Russia that will go to the North Pole. And so they've been monitoring it, and it's been moving. So it's different from the actual North Pole location. Okay? Here we can see it a little bit on the South Pole. It's also different. The magnetic South Pole is moved away from the true axis point. Now, typically when this happens, when the magnetic poles move, the actual poles will move to go and meet them. The magnetic poles move first, and then the pole shift comes when the axis turns and goes towards the magnetic section. And that's what's happened here. This is Australia over here. This is Antarctica, South America over here. So the South Pole has been moving, South Magnetic Pole has been moving, and the North Magnetic Pole has been moving, and in fact, we have been moving. But let me explain to you how the Earth is made. This is theoretical because nobody's drilled down there this deep to know. But what we believe is there is the crust, the core starts in here, this mantle, and this area is a solid mass, and this area here is a liquid mass of molten magma, and this is made out of iron and nickel, so that when the electrons come across the top and the bottom, this is the north is a positive, the south is a negative, and it creates an electromagnetic flow through our planet, which builds a atmosphere protection device we call the magnetosphere. So, if you look at this, you see there's nothing special. This is like the inside of a golf ball. There's no pole running up and down, causing the Earth to tilt on a turn on a certain point. So this can easily change. The rotation can go from here, it can move over to here, and it can rotate this way now. And I have a video that where a woman explains. I'll put it in the description, where a woman explains what a major pole shift is like, and she's got a really good model. So she says she got it from a dream, which I don't know if the dream is accurate, but the model where she explains it's very good. So that's why I reference it. All right, so this is the way the science explains it. Our rotation of axis is right here, and we're rotating this way right now, but this is the way, this goes out to the sun, and this goes out to the other planets in our solar system on the ecliptic, this is called. So Mars and Venus and others are out here, and Mercury is up this way. But what we're tilted over to the right, and we're twisting in a different direction. And the important thing about all of this is that the equator is halfway, and it's going like this. So if we have a pole shift, which we have, the equator will also change. So this North Pole is going right through here. This is the typical equator we've talked about, and this is the way it looks when we spin. All right, the sun is over here, and the rest of the solar system is out here, and we're spinning this direction. And the tilt will change according to the seasons. It goes much more than it goes back and forth, tilting back and forth, so that different places get different amounts of sun. Okay, so is this unusual? No. According to the typical science, our Earth is tilted at 23 degrees. Uranus, another planet in our solar system, is treated 97 degrees. Venus, 177. There's a lot of them. In fact, all of them are tilted, and ours is tilted as well. All right, now, if you do the science on this, they will tell you that the North Pole, the axis of rotation, is pointing towards a star called Polaris, and we know that commonly as the North Star. Every Boy Scout has learned this. And the difference between the actual North Pole and the center of the planet is called the tilt. And for a number of years, I don't know, maybe 3,500, the tilt of our planet has been 23.5 degrees. Okay? And it changes a little bit, a degree or so, plus or minus, but it's been approximately 23 degrees. However, recently, within the last year, another heavenly body, the brown dwarf, has grabbed our planet and twisted it more so that the North Pole is no longer pointing to the star Polaris or the North Star. If you were a good Boy Scout and you know where the North Star is, you can go out at night and you can look and see the North Star is not in the location you remembered it. It is in a different location. Now, the stars have not moved, okay? It's us who have moved. And the stars will stay up there as constellations, stay up there. But you can look and you can see the North Star is not the same place. But more importantly, the equator has changed too, and it's shifted slightly. So the equator now has come up a little higher in certain areas. In the place I'm at, we used to be at 11 degrees north of the equator. I estimate we're right on the equator now. The temperature and the weather patterns fit that exactly, and based upon my observations, we're actually at the new equator. Now, you can test this for yourself. You don't have to just take my word for it. Go out at night and look to where the sun sets, and you will see that it's setting further in the south. Or in the morning, get up early and go out and see where the sun comes up, and you'll see it doesn't come up in the same spot that it used to. It's coming up towards the south. Now, I know this video is recorded in November, and November 21st in the northern hemisphere is what's commonly called the shortest day, or the winter solstice. That's when the tilt will be at its maximum for the northern hemisphere. So I understand that it's going to be a little bit more because of that. But you will see, especially people who are over 40 years old, that there's something really different. That the sun is in a totally different position. You've never seen it down there in your life, and it's more to the south. Now, again, we don't get to see these too often because we have so much cloud cover. But just watch for it. You'll see. This is what I call a minor pole shift. It's already taken place. It's not being discussed in any of the broadcast media or any place else in the mainstream media because they don't want us to talk about this stuff. They don't want us to know. They want us to be caught by surprise by the enormous red dragon next September. So none of this is being discussed, even though the people at the top, the people in the Vatican, they all know about this. This is not a secret. So watch for the sky, watch for the sunrise and the sunset. You'll see they're in different places than they ever have, and you'll be able to tell that the pole shift has taken place. And especially if you don't know where the North Star is, ask a friend. Maybe they can point it out to you. It's where you can see it through the Big Dipper, but you'll see it's in a different place. In the Philippines, it's quite noticeable. And when I tell people, I'll go out at sunset and I'll say, look, the sun is setting there, and it's not supposed to set there. It's supposed to set in this other location. And they're listening to me, but not very much, because they're staring at the sun. And they're looking at it, and their brain is trying to compute. They know that's the sun. They know it's setting, but it's in the wrong location. All their life, the sun is set over to the right more. It's more to the left now. It's towards the south, and it's because of the pole shift. So it's a minor pole shift, but it's more evidence that we have a brown dwarf in our solar system, and it's having an effect on our planet. So I hope you enjoyed this. If you want more videos, support and see what we can do. Thanks.